Samuel, a motorist, uses 24% of his fuel in covering the first 20% of his total journey in city driving conditions. If he knows that he has to cover another 25% of his total journey in city driving conditions, what should be the minimum percentage increase in the fuel efficiency for non-city driving over the city driving fuel efficiency, so that he's just able to cover his entire journey without having to refuel? And clearly he has mentioned that we can do an approximate calculation. So let's reread the question and understand what it actually means. So he says Samuel, who is a motorist, has used 24% of his fuel in covering the first 20% of his total journey. Understand, he has covered only 20% of his journey, but already 24% of the fuel is over. Which means if he goes at this rate, he will not be able to cover the journey without refueling. See, the whole concept here is that he has to cover the entire journey. He is able to cover his entire journey without having to refuel. So he should not refuel. He should not get more fuel in his vehicle. Without getting any more fuel, he should cover the journey. So if that is the constraint, then there is a difficult situation here, because 24% of the fuel is already over, has been utilized in covering only 20% of the journey, in covering just the 20% of the journey. And this is in the city driving conditions. Now understand, the question is talking about two types of conditions: city driving conditions and non-city driving conditions. Now read the next part. If he knows that he has to cover another 25% of his total journey in city driving conditions. He has already covered 20% of his journey in city conditions. Another 25% has to be covered in city conditions. What should be the minimum percentage increase in the fuel efficiency for non-city driving over the city driving fuel efficiency? Now, what is this fuel efficiency? Fuel efficiency in simple words is mileage. I'm sure the word mileage is more popular among Indians, right? You know what is mileage, right? Kitna deti hai? The first question that we ask, the Indians ask as per a popular Maruti ad series, right? Kitna deti hai? So mileage, what is the mileage? So basically he says what should be the minimum percentage increase in the mileage for non-city driving over the city driving mileage, so that he's just able to cover the entire journey without having to refuel. So I'm sure all of you have understood the context. Basically, when he is driving in the city, he consumes more fuel. 24% is gone in 20% itself, in 20% distance itself. Another 25% distance has to be covered in city only. So obviously for him to cover the entire journey without refueling, the mileage in the non-city conditions should be far better than the city conditions. Okay, so let's work on this one now. Now total distance is 100%. You don't have to write this step, but for the sake of explanation, I'm just putting it here. Total distance is 100%. Let's break this 100% into two parts: city driving and non-city driving, city conditions and non-city conditions. How much of this total distance is going to be covered in city conditions and what percentage will be covered in non-city conditions? How much is in the city conditions? See, in the first 20% was in city conditions, another 25% is also going to be in city conditions. So I can say 20 plus 25, which is equal to 45%. So 45% of the distance will be covered in city conditions, which means obviously remaining 55% will be covered in the non-city conditions. If you're covering 45% in city, then 55% has to be covered in the non-city conditions, because total is 100. So that is clear, right? 45% in city, 55% in non-city. Now let us understand that what is the fuel consumption for these two. How much is the fuel consumption? You understand? You're able to follow. Again, total fuel is also 100%. The total fuel that we have is also 100%. I mean, just go by percentage, right? Total fuel is also 100%. So we now have to break up this 100% into two parts. How much of the fuel is available for city conditions and how much fuel is available for non-city conditions. How do you do that? This looks like not very readable. Let me rewrite. Don't do this in the exam, please. Only for the sake of explanation. Total fuel. Total fuel is 100%. We have to break that, like we have split 100% of total distance into 45 and 55, city versus non-city. Let us do the same thing for fuel as well. How do you do that? See, we know that 24% of the fuel got over in 20%. In city, he spent 24% of the fuel to cover what distance? 20% distance. Remember, the fuel consumption and distance are proportional, right? As the distance increases, the fuel consumption increases. As the distance decreases, the fuel consumption would decrease. So I know that 24% of the fuel is gone. 24% of the fuel is gone in covering 20% of the distance. So how much fuel will be required to cover 45% of the distance? Remember, we are talking about city conditions, right? City conditions. This is fuel and this is distance. 24% of the fuel was utilized in 20% of the distance. Total distance to be covered in city is how much? 45. So for covering total 45% distance, how much fuel will be required is a question. How do you get that? Cross multiplication. Why is cross multiplication possible here? Because these are directly proportional. When two parameters or two variables are directly proportional, you can cross multiply to evaluate. So do that. How much will that be? 45 into 24 upon 20. 45 into 24 divided by 20 will give you a question mark. Simplify this now. So this is 5 into 9, 5 into 4. This is 4 into 1, 4 into 6. So 9 6 is how much? 54%, which means 54% of the fuel was consumed in city conditions itself. So what is the balance? 46%, and that 46% is available for non-city conditions. You getting it? So now you have to understand that 54% of the fuel is available for covering 45% of the distance, and 46% of the fuel is available for covering 55% of the distance. So obviously the mileage here is lesser than the mileage here, right? What is mileage? Mileage here is nothing but what? Distance by fuel, right? Fuel economy or fuel efficiency, whatever you call it, right? Distance covered by fuel used. That's what is mileage, right? Mileage is nothing but distance covered by fuel used. So we know the distance covered, we know the fuel used in both city versus non-city conditions. Yeah, distance covered, fuel used, distance covered, fuel used. So can you find out the mileage for both city and non-city? Yes. Once you get the mileage for both city and non-city, can you find out the percentage increase in the fuel efficiency, which is mileage for non-city over city? Yes. So I think two more steps. First, find out the mileage for city, mileage for non-city, and then calculate the percentage increment. So let me do that. So I'll call it fuel efficiency. Mileage is nothing but fuel efficiency, right? So let's do the next step. Now fuel efficiency for city conditions. How much is that? See, fuel efficiency is distance by fuel. How much distance? 45% distance. Divided by fuel, 54. Right? What is the fuel efficiency for non-city? Fuel efficiency for non-city, distance by fuel again, right? So distance covered is 55%. And this is 46%. See, strictly speaking, this is 45% of D, 54% of fuel, 55% of D, 46% of fuel. But eventually we are going to do a percentage based calculation, right? So those will anyway get cancelled. So we are not worried about it. Now you have to find out what the percentage, minimum percentage increase. Percentage increase. Percentage increase of what? Non-city versus city. So X is what percentage more than Y? X minus Y by Y into 100. X is what percentage more than Y? X minus Y by Y into 100. Yeah. So just do that calculation. X minus Y by Y into 100. What is X here? 55 by 46. See, this is how much more than this? X is what more than Y? X minus Y by Y. So 55 by 46. It is going to be like this. 55 by 46 minus, I think this can be taken as 5 into 9 and 6 into 9, right? 9 into 6, 9 into 5. 5 by 6. This is equal to 5 by 6. Simplification here is not possible, but this can be. Or approximate calculation he has said, right? So approximately, I think 55 by 46 can be taken as 11 by or 5 by 4, no? We have to do an approximate calculation. See, if options were given, it would have been a lot easier. But since options are not given, we don't know to what extent the approximation can be done. So I'll do one thing. For the sake of approximate calculation, I'll just clear this up. Right? Let's approximately take this as 5 by 4. See, this is 11 into 5. This is 11 into 4. 11 into 4 is 44, but 46 is very close. So this is 5 by 4. Yeah. So fuel efficiency in city is 5 by 6. Fuel efficiency in non-city is 5 by 4. So non-city is how much more than city? So 5 by 4 minus 5 by 6 divided by 5 by 6 into 100. X is what percentage more than Y? X minus Y by Y into 100. Or you can directly do the percentage also. 5 by 4 is like 125 or 1.25. 5 by 6 is 83.33. So based on that you can do it. Yeah. Simplify anyway. What do we get? So 5 in the numerator gets cancelled. We don't have to worry about that, right? 5 is there in the numerator everywhere. So if you take 24 as LCM, 6 minus 4, 2. 2 by 24 by 1 by 6. 2 by 24 by 1 by 6 will become 2 into 6 by 24. 12 by 24. 12 by 24 is 1 by 2. 1 by 2 is 50%. Approximately 50%. Again, like I said, this is an approximate calculation where we have in fact taken too much of approximation. We have taken 55 by 46 as 55 by 44. You understand? The actual numerator is 46. Actual denominator is 46. Approximated denominator is 44. If the actual denominator is more, actual value will be less, which means 5 by 4 will be less, actual value is less. If this actual value is less, overall answer will also be less. So answer I can say should be less than 50%. So even if there are two options which are close to 50, but one is less than 50, the other more than 50, you can take the answer as whatever is lesser than 50 there. Yeah. If you say no, how can you take 46 as 44? That's too much of approximation. Then take the actual value and do the calculation. I mean, that's your lookout. Yeah, calculation is your problem. But the answer comes out to be 50%, approximately 50%, less than 50%, strictly speaking.